Welcome to MyESAT's SAT Essentials video series. This is a 10-hour video, personally paced SAT program that's designed to provide quality SAT preparation to all students. The series is split evenly between the three sections of the SAT: math, writing, and critical reading. The lectures cover effective SAT test-taking strategies, review frequently tested topics, and provide practice problems that familiarize and prepare students for the real exam. The SAT Essentials video course is the foundation for all MyESAT courses and is used in conjunction with live MyESAT workshops. At MyESAT, our mission is to pave the way for brighter futures empowered by education for all students.
Hi, Ryan here again, and welcome to our second math class in MyESAT's SAT Essentials video course. Woohoo! That means after this class, you're 2/3 of the way done with math. And if that fraction confuses you, then yeah, you really do need to pay attention more in math class. Remember, as you work your way through this video, it's not enough to just passively watch these lectures and shut your eyes and daydream about girls or guys, whatever your thing is. I need you to do all the questions on the screen with me and also jot down important notes that'll help you remember what we talked about today. It's important to pay attention because SAT math ain't no joke. Know what I'm saying? We have some challenging stuff coming up. I remember back when I took the SATs, my dad never really understood what was so hard about SAT algebra and arithmetic. My dad's an electrical engineer, so he's super good at math. When I'd miss a whole bunch of math questions, he would say, "Son, I don't understand why you missed math questions. How can algebra be that hard? What's going on? Why don't you like my mustache?" Yes, because SAT math concepts may not be complex, but there's a lot of times on the SAT that those simple arithmetic and algebra questions will be asked in such a tricky way that even people good at math get confused. What makes a question so tricky is that test makers are often testing the way you think, not necessarily just the math concept itself. And that's why the SAT is so different than the test you take in high school. But you know, because it's that tricky, that just means you gotta learn the tricks. That's why we're here now. The SAT is kind of like baseball, where almost nobody is good at first once they set their foot on the field, but everybody gets much better through practice. And so will you. You just got to review the material and you got to practice. Then you will improve. I guarantee it. And this course will help. Today we're going to review math concepts that will appear on every single SAT test. So if you're ready, I sure am, let's get our foot on the court. I meant field, it's baseball. And start practicing. Do you have your notebook and pencil ready? I hope so, but if not, let's take a quick pause and grab them. Alrighty, you got them? Then let's go. Play ball.
You remember Jake, your math TA, don't you? He's back today to help me cover important points. Ladies, I know he's a good-looking dude, but remember, yes, he's just a cartoon, and no, he cannot take you out on real dates. Today we're going to review all the most important topics in arithmetic and algebra on the SAT, such as integers, factors, multiples, prime numbers, exponents, and functions. Integers. So what is an integer? Well, you probably know integers are numbers like 1, 2, 3, and 4. But what about -1? Is that an integer? And what about 0? Is that an integer? This is where knowing the exact definition of an integer comes in handy. An integer is just a fancy name for any whole number. So is -1 a whole number? Yes, whole numbers can be negative. Is 0? Yes, 0 is a whole number too. Integers can be negative or 0 as long as they are a whole number. Write that down, because when a question asks you about integers, it is important to know what they are. Now on to factors. So what is a factor? What does it mean when we say one number is a factor of another? A factor is a number that divides into a larger number with no remainder. You can remember it this way. You know how if you say, okay, money is a factor in my decision, it means that money is a part of your decision. Well, for math factors, it is the same. If a number is a factor of a larger number, it means that number is a part of the larger number, i.e., it can be divided into the larger number. For example, what are the factors of the number 12? Draw a factor tree as on the screen. Factors of 12 are 1 and 12, since 1 and 12 divide into 12 with no remainder. Also, factors are 3 and 4, as well as 6 and 12. So the factors of 12 are 1, 2, 3, 4, 6, and 12. Awesome. So what are multiples then? Well, they are the exact opposite of factors. Specifically, multiples of a positive integer are those that have it as its factor. So that means if factors are divisible into a number, then multiples are multiples of that number. So what are the multiples of 12? For example, to find multiples of 12, you would multiply 12 by 1, then by 2, then by 3, and so on. Therefore, the multiples of 12 are 12, 24, 36, etc. Next up, what is a prime number? A prime number is a number that has two factors. One, itself. The first 10 prime numbers in increasing order are 2, 3, 5, 7, 11, 13, 17,
19, 23, and 29.
Jot those down in your notebook and make a note next to it that says, memorize these numbers. Trust me, SAT test makers love throwing in questions about prime numbers. Know how to recognize them and also make sure you can count them out quickly. That's a piece of knowledge that may very well come in handy. However, let me point out a couple things. Notice that 1 is not a prime number. Why is that? Well, because it only has one factor, 1. Think about it. 1 times 1 equals 1. Therefore, the only factor 1 has is 1. Also, please note that there is only one even prime number, 2. No other even number is a prime number. Any other even number would always be divisible by 2, correct? That's why 2 is the only prime number. Now it's time to learn about inequalities. There are so many inequalities in this world. Like when someone is born with perfect hair like Justin Bieber, and someone else is born with hair like Donald Trump. See? Obvious inequality. Well, math inequalities are similar. It's when one side is unequal to the other side. There are 4 inequality symbols as on the screen. Inequalities can be treated in equations exactly like an equal sign, meaning you can add, subtract, multiply, or divide both sides of the equation by the same number. The only exception is if you multiply or divide an inequality by a negative number. If you do this, then the inequality flips over, so the side that was greater than before suddenly is less than now. As you see on the board, when you divide by a negative number, the inequality flips.
Okay, let's stop for a second and take a moment to quickly recap everything we just reviewed. If you didn't jot down notes before, jot them down right now. You in the back, man, I'm looking at you. Get that pen and paper out. Number 1, a factor is a smaller number divisible into a larger number. Number 2, a multiple is the opposite of a factor. It is the larger number. And number 3, you need to memorize the first 10 prime numbers. It's not hard, write them down now. 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. Number 4, an inequality is treated just like equations, except that when you divide both sides by a negative number, then the inequality gets flipped. Alrighty then, that was probably mostly a review for you, but here comes the tricky part. How do we apply this knowledge to real SAT questions? Let's try a couple. I'll give you a minute to complete the question on the screen.
Okay, let's go over the solution together. So this is an example of an easy level inequality question. You want to solve for x. First we'll subtract each side by 6. The inequality is preserved and you get negative 3x is greater than 18. The next step is to divide both sides by negative 3. Because negative 3 is a negative number, the inequality flips. It is now x is less than negative 6. Sweet! Easy, right? Well, that's just to get you warmed up. Now let's try a medium level inequality question. I'll give you another minute to solve. Let's go over the answer. Because there is an absolute value here, you must separate the inequality into two separate pieces. One piece is 3 minus x is less than 2, and the other piece is 3 minus x is greater than negative 2. Notice that the second inequality flips when you set it to negative 2? This will always be the case when you are dealing with an absolute value in an inequality equation. Okay, that's the tricky part. Now let's just solve using algebra. You end up getting x is greater than 1 for the first piece, and x is less than 5 for the second piece. Now the question asks, which of the following is a possible value of x? Well, which of the answer choices fits both pieces of this inequality? Answer choice A does. 4 is both greater than 1 and less than 5. Perfect! Or, another way to solve this problem is to use the plug-in answer choices strategy we learned in Math Class 1. Exponents are these little numbers you see written at the top right-hand corner of a number, almost sticking out. What it is just a shorthand way of writing multiply this number by itself a certain number of times. For example, 3 to the fourth means 3 times 3 times 3 times 3. So 3 to the fourth means multiply 3, the base, against itself 4 times, the exponent. Bet you already knew that, right? But it gets a little bit more complicated. There are certain properties of exponents that you should know in order to help you solve exponent problems on the SAT. As I go over these 7 exponent laws, jot them down. Law 1. If you are multiplying exponents with the same base, then you can add together the powers. So 3 to the second times 3 to the fourth equals 3 to the sixth. Law 2. If you are dividing exponents with the same base, then you can subtract the powers. So 3 to the second divided by 3 to the fourth equals 3 to the negative second. Law 3. If you have an exponent taken to another power, then you can multiply the two exponents together. So 3 squared to the fourth power is really 3 to the eighth power. Law 4. Any exponent to the 0th power equals 1. Law 5. Any number with a negative exponent is the same as the reciprocal of that number with a positive exponent. So 3 to the negative squared equals 1 over 3 squared. Law 6. This is really the same as Law 5, except the reverse. It says that any positive number with a positive exponent can be rewritten as the reciprocal of that number to the negative exponential power. So 3 squared equals 1 over 3 to the negative 2 power. Law 7. This law is really hard to explain in words, so let me just show you what it does. 3 to the 2/4 power turns into the quad or fourth root of 3 squared. You see? the denominator of the exponential fraction became the root and the numerator of the fraction stays the power. Exponents can be a bit tricky, but you definitely must learn these 7 laws. Here's an additional tip that will help guide the way. Make the bases the same. That's because these 7 laws of exponents only work if the bases are the same. So first thing you should do when solving equations with exponents, try to manipulate the equation so all the bases are the same. Let me show you what I mean with a question. You'll have 1 minute to try to solve it on your own. Let's go over the solution now. Okay, so as you know, our goal here is first to make all the bases the same. Looking at the question, that means making all the exponents have a base of 2. Let's see how we can use the 7 exponent laws to do this. Let's apply law 5 to the right side to convert both sides to the same base of 2. Law 5 states that we can rewrite 1/2 to the x power to 2 to the negative x power. Right? We're flipping the numerator and denominator and changing the exponent from positive to negative. So now all exponents have a base of 2. On the left-hand side, we can combine our 2 to the x powers to 2 times 2 to the x power. From here, it gets easier. Let's divide both sides by 2 to the x power. Using law 2, we know that when dividing exponents with the same base, you can subtract one power from the other. So we get 2 equals 2 to the negative 2x power. Because now both sides have the same base, we can set the exponents equal to each other. 2 has an exponent of 1. Therefore, we can set 1 equal to negative 2x. Using algebra, we get x equals negative 1/2. Perfect! Whew! That was a lot of manipulating the equation. I gotta take a shower. But note how crucial our laws of exponents were to solve this problem. Okay, let's try one more. I'll give you 1 minute to do this question on your own. Good luck! Time's up. How'd you do? Let's go over the answer together. First, you want to apply Law 5, which says you can rewrite y to the negative first power as 1 over y. So when you rewrite it, you get x squared over y equals 10x. Next, multiply both sides by y. Then you divide both sides by x. Now you know what x is, but remember, you are trying to solve for x to the negative 1. Therefore, you should raise both sides to the negative first power. Then you can rewrite that as x to the negative first equals 1 over 10y. D is correct.
Exponents are definitely challenging. We'll go over exponents in more detail in our live workshop, Math Concepts, Set A.
So how do functions function? A linear function is the equation for a straight line. Pretty crazy, right? How a bunch of numbers and letters can represent a line? But it's true. Every line on a graph, even the one on the board, has a unique equation. The standard form which we write the function of a line is y equals ax plus b. Y and x in the equation represents every x and y coordinate on the line, so we leave those as variables in the equation since they have many values. A, on the other hand, only has one value. It represents the slope, or steepness or incline, of the line. B likewise has one value, and that's the y-intercept, or the y-coordinate of where the line intersects the y-axis. You might be like, hey, I've seen that equation before. Well, the standard form is also sometimes called the slope-intercept form. Okay, let's talk slopes now. You can determine a few things about the slope of a line without doing any calculations at all, just by looking at it. If it's going up, that tells you it's a positive number. The steeper it is, the higher the positive number is. So a line with a slope like the one on the board might be a 4. This next line might have a slope of 1/2. And if it's going downwards, then we know it's a negative slope. Similarly, the more steeply it's going down, the lower the number is. So how do we find the exact slope of a line? You can do it if you know any 2 points of the line. Here's the equation for slope given 2 points. You subtract the y-coordinates and put it on top, and then subtract the x-coordinates and put that on the bottom. Or one way to think about it is rise over run. Alright, did you write this down? Because we're going to try a problem now, and just a hint, you're going to need it. You have 1 minute. Good luck! So, how'd you do? This question is a classic slope question. As long as you know your slope formula, it shouldn't be too difficult to solve. Alright, so remember our slope formula is slope equals y2 minus y1 over x2 minus x1. Let's plug in the numbers the question gives us. We know the slope is 1/6, y for y2, 1/3 for y1, 6 for x2, and 0 for x1. Now multiply both sides by 6 to get rid of the fraction. You get 6 equals 6y minus 2. Then do the math and get y equals 4 over 3. Alright, next question. I want you to really rock this one. 1 minute, starting now. Alright, so this problem is asking you to find the x-intercept of this line. Well, what do we know about x-intercepts? It's where the line hits the x-axis, meaning at that point the y-coordinate equals 0. So let's take our original equation for the line and plug in 0 for y. From here, just solve it out until we get that, x equals 2. And that's our answer. The x value is 2 at the x-intercept. Making D the correct answer. Before we wrap up linear functions, here are some other fun facts. Fact 1. A horizontal line has a slope of 0. This is always the case. For example, a horizontal line might have the equation y equals 5. Fact 2. A vertical line has an undefined slope, so you can't write the equation for a vertical line in the standard form. Instead, the equation looks like x equals constant. So an example of a vertical line would be x equals 4 or x equals 7. Fact 3. Parallel lines always have the same slope. Fact 4. Perpendicular lines have negative reciprocal slopes, meaning if one line has the slope of 2, then the perpendicular line would have a slope of negative 1/2.
Wow, I told you those fun facts were fun. If they weren't fun, they'd be called not fun facts. Get it? Nyuk, nyuk, nyuk. To learn more about linear function and those scary quadratic functions, sign up for our workshop, Math Concepts, Set A. Ba-dum, ba-dum. All right, let's end this lecture strong with some practice questions. These will test you on the same concepts that we covered today, and we'll go over the correct answers at the very end. Good luck! Time's up! Let's go over the solutions for each problem. Question 1. If x and y are positive integers, and 2 to the 2x power times 2 to the 2y power equals 64, what is the value of x plus y? So the first thing I notice about this equation in this problem is that x and y are in the exponents in our equation. So that makes it a little trickier. Okay, and next, what do you notice about the base of the two exponents? They're both 2, right? So this tells me I can use my law of exponents and combine the two numbers by adding the exponents. So 2 to the 2x times 2 to the 2y becomes 2 to the 2x plus 2y. Now we have that equals 64. And how can we make 64 have a base of 2? Let's see. 2 to the 4th power is 16, 2 to the 5th is 32, and 2 to the 6th is 64. Perfect. Let's rewrite 64 as 2 to the 6th. Now, we can set the exponents equal to each other, so 2x plus 2y equal to 6. Divide both sides by 2 to get x plus y equals 3. And now let's look at our answer choices. Yep, 3 is answer choice C, so C is correct. Question 2. If x to the second over y is an integer, and x over y is an integer, which of the following could be the values of x and y? For this type of problem, which strategy would work well with this problem? Well, notice we're dealing with an integer problem with the variables x and y. And look, our answer choices are numerical values. So that tells me we should use our Goldilocks strategy. Let's start by plugging in answer choice C. So x equals 3 and y equals 2 into the problem and see if it fits our requirements. Let's choose the simpler equation to start with, x over y. Is x over y or 3 over 2 an integer? That gives us 1.5, which is not a whole number, which remember is the definition of an integer. Let's scan the rest of the answer choices and eliminate the ones that don't give us x over y as an integer. So 1 over 0 is not a real number, much less an integer, so let's eliminate A. 1 over 2 is not a whole number either, so let's eliminate B. And 3 doesn't divide into 5 evenly either, so answer choice E is out. So we're left really with only one viable answer choice. Answer choice D. 4 over 2 gives us 2, which is a whole number and an integer. Let's make absolutely sure this is our right answer and plug in x equals 4 and y equals 2 into x to the second over y to make sure that's an integer as well. 4 squared equals 16. Divide that by 2 and you get 8. That's definitely a whole number. So answer choice D must be our correct answer. I knew you can do it. You're so smart. Question 3. Line L goes through points 0, 1 and 3, 0. If line N is perpendicular to line L, what is the slope of line N? Alright, so to solve this problem, we'll have to draw on our slope formula. We're given 2 points on the line, so let's plug those 2 points into our slope formula. Remember, whenever you have any 2 points on a line, you can always find the slope of the line. Okay, so put 0 minus 1 on the top and 3 minus 0 on the bottom. You find out that the slope of line L equals negative 1/3. But the question is asking us for the slope of line N, which is perpendicular to line L. Remember from our fun facts that the perpendicular line always has a negative reciprocal slope. So what's the negative reciprocal of negative 1/3?
To find the negative reciprocal, you flip the numerator and the denominator and change the power sign. So a negative 1/3 becomes a positive 3. And that, my friends, is our correct answer, making answer choice E correct. Question 4. If m is the greatest prime factor of 32 and n is the greatest prime factor of 100, what is the value of m plus n? Alright, so for this question, it's testing our knowledge of prime numbers and factors. Let's show them what we got, kids. Let's first find all the factors for 132 by drawing out their factor trees and then identifying the greatest prime factor of each. Okay, so a factor tree for 100 would look like this. You factor out a 2 and get 50. Factor out another 2 and get 25. Well, 25 factors down to 5 and 5, which is a prime number. So that's your greatest prime factor for 100. Now let's take a look at 32's factor tree. Factor out a 2 and get 16. That factors down to 4 and 4. And those each factor down to 2 and 2. 2 is a prime number. Remember, our smallest and only even prime number. So this is 32's largest prime number. M equals 2 and n equals 5. Add 2 and 5 together and you get 7. That makes A our correct answer choice. Boom shakalaka.
Alright guys, now I have homework for you. You finished the lecture for Math 2. Congrats. After you finish watching Critical Reading 2 and Writing 2, it's time for some real practice. These strategies have given you guys some serious Kung Fu skills. Now go put them to use on the real thing. From Official SAT Study Guide by College Board, take Practice Test 3. Math is a tricky section of the SAT, but don't worry, it is very a coachable section. It's all about practice, 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 and practice, and more practice. Students who don't give up always improve their scores on the SAT. That's my guarantee to you. So head up, please. We'll cover the concepts taught today and many others in Workshop Math Concepts Set A. This brings us to our end of class comic. Until next time, peace out, Home Slice.